In this video, we'll solve an applied problem involving an ellipse. There are many real-world applications for ellipses, including orbits of planets, satellites, moons, the shapes of boat keels and rudders, and certain airplane wings. The applied problem we'll be working on today involves whispering chambers, which are buildings designed with elliptical domes so that a person standing at one focus and whispering can be heard by someone standing across the room at the other focus. This occurs because of the acoustic properties of an ellipse. As a sound wave originates at one focus, the sound wave will be reflected off the elliptical dome and directed back to the other focus. We can see a picture of this on our slide. There is a whispering chamber at the Museum of Science and Industry in Chicago, and also in our example, the whispering chamber in the Statuary Hall of the Capitol Building in Washington, D.C. The Statuary Hall is 46 feet wide and 96 feet long. We can see a picture of the room represented as an ellipse on this slide. The orange arrows are representing how the sound would be reflected by that elliptical chamber from one focus point to the other. Today we want to locate the foci of a whispering chamber. The first step is to write the standard form of the equation of the ellipse representing the outline of this room. We will start by making the assumption that our ellipse is horizontal with a major axis on the x-axis, and we will let the center of the room be represented by the point 0, 0, also known as the origin. The standard form of an ellipse centered at 0, 0 with a major axis on the x-axis is x squared over a squared plus y squared over b squared equals 1, where a is greater than b, the length of the major axis is 2a, coordinates of the vertices are plus or minus a, comma 0, the length of the minor axis is 2b, the coordinates of the covertices are 0, comma, plus or minus b. The coordinates of the foci are plus or minus c, comma 0, where c squared equals a squared minus b squared. First, let's determine what is the length of this room. We saw in previous slides that the length of the room was 96 feet. This is longer than the width and will correspond to our major axis. Remember, the formula for the length of the major axis is 2 times a. Therefore, 2a equals 96 feet. We divide both sides by 2, giving us a equals 48 feet. We can square 48 feet and we get 2,304 as the value for a squared. Next step, what's the width of the room? This is our minor axis. The width of the room is 46 feet. And the formula for the length of the minor axis is 2b. Therefore, 2b equals 46 feet. We divide both sides by 2, and we get b equals 23 feet. When we square 23, we get b squared equals 529. Remember, the standard form of an ellipse centered at the origin, the point 0, 0, with a major axis on the x-axis is x squared over a squared plus y squared over b squared equals 1. We now know a squared is 2,304 and b squared is 529. Therefore, the standard equation of this ellipse is x squared over 2,304 plus y squared over 529 equals 1. The second part of our question is how to locate the foci now that we have the standard form of the equation. Pretend two senators are standing at the foci of the room and they can hear each other whisper. How far apart are they standing? We have to calculate the distance between the foci. Remember, our horizontal ellipse has a major axis on the x-axis. This means its foci will have the form plus or minus c, comma 0, where c squared equals a squared minus b squared. We know a squared equals 2,304 and b squared equals 529. Therefore, we must solve c squared equals 2,304 minus 529. We enter that into the calculator. We find c squared equals 1,775. We square root both sides, and we get the square root of c squared equals the positive or negative square root of 1,775. Enter that into your calculator, and we will find that c equals approximately plus or minus 42. That's an approximation. We're talking about feet, so we just round it up to the nearest whole number. The points positive or negative 42, 0 represent the foci of this ellipse. Recall that the distance formula states the distance between 2 points is equal to the square root of the second x coordinate minus the first squared plus the second y coordinate minus the first squared. That gives us the distance equals to the square root of 42 minus negative 42 squared plus 0 minus 0 squared. 0 minus 0 squared is just 0, so that piece goes away. 42 minus negative 42. Remember, a negative times a negative gives us a positive. So we have 42 plus 42 squared, which is 84 squared. And we find that the distance between our two centers is 84.